Right now, there is a growing cybersecurity emergency happening across the internet, and most people are completely unaware of it. Security researchers are warning that hundreds of thousands of Linux servers, possibly more than 800,000 systems worldwide, are directly exposed to the public internet with weak configurations, outdated software, or dangerous security gaps that attackers can exploit in minutes. This is not some distant theoretical problem that only affects giant corporations or government agencies. It affects cloud servers, VPS hosting, small businesses, developers, startups, universities, home labs, and even personal self-hosted systems. The scary reality is that many of these servers are vulnerable because of very small mistakes that administrators never realized could become major security risks. Linux powers the internet. Most websites, cloud platforms, containers, AI infrastructure, enterprise applications, and backend systems rely heavily on Linux distributions like Ubuntu, Debian, Red Hat Enterprise Linux, Rocky Linux, Alma Linux, SUSE, and Arch Linux. When people think about malware and hacking, they usually imagine Windows PCs getting infected with viruses. But modern cybercriminals increasingly focus on Linux because Linux systems control valuable infrastructure. A compromised Linux server can provide attackers with access to databases, websites, internal company systems, customer information, and huge amounts of computing power. One of the biggest misconceptions in the tech world is the belief that Linux is naturally immune to attacks. Linux can absolutely be extremely secure, but only if it is configured and maintained properly. A poorly secured Linux server connected directly to the internet can become a target within minutes of going online. Cybercriminals now use highly automated tools that continuously scan the internet searching for vulnerable systems. They are looking for open SSH ports, outdated web servers, exposed Docker APIs, weak passwords, unsecured databases, Kubernetes dashboards, FTP servers, and unpatched software vulnerabilities. The moment a new server appears online, attackers often detect it almost instantly. Security researchers who deploy intentionally vulnerable honeypot servers regularly observe brute force login attempts within minutes. Bots constantly scan public IP ranges across the internet searching for systems running Linux services. These attacks are not usually performed manually by a hacker sitting behind a keyboard. Modern cybercrime is heavily automated. Massive botnets and scanning tools work around the clock probing systems for weaknesses. If they find one vulnerable entry point, exploitation begins immediately. SSH is one of the most common attack targets. Secure Shell is essential for remotely managing Linux servers, but it is also heavily abused by attackers. Many administrators still expose SSH directly to the public internet without proper protections. Some allow password-based authentication instead of secure SSH keys. Others leave root login enabled remotely. Weak passwords remain an enormous problem. Automated scripts continuously attempt millions of username and password combinations against public-facing servers. Logs from Linux systems often reveal thousands of failed login attempts every single day. Another huge issue is outdated software. Linux servers depend on countless packages, libraries, and services that require regular security updates. Vulnerabilities are discovered constantly in software like OpenSSL, Apache, and Nginx, PHP, xmsudo, Samba, and even the Linux kernel itself. The moment security researchers publicly disclose a serious vulnerability, attackers rush to weaponize it. Exploit code spreads rapidly online, and systems that remain unpatched become easy targets. Unfortunately, many administrators delay updates because they fear downtime or compatibility problems. Some servers remain unpatched for years, creating a perfect opportunity for attackers. Cloud computing has made the problem even worse. Today, almost anyone can launch a Linux server in minutes using platforms like Oz, Azure, Google Cloud, DigitalOcean, or Hetzner. This convenience is powerful, but it also means many inexperienced users are deploying servers without understanding security fundamentals. Someone might launch a VPS for a website, game server, or development project, and forget to configure a firewall entirely. Others expose sensitive services directly to the internet without realizing the danger. Containers and Kubernetes environments have created additional attack surfaces. Docker made deploying applications incredibly easy, but many users accidentally expose Docker management interfaces publicly. An exposed Docker API can allow attackers to create malicious containers or gain root-level access to the underlying host system. Kubernetes clusters are even more complex. Misconfigured dashboards, insecure permissions, and exposed APs have resulted in countless real-world compromises. Attackers specifically scan for these mistakes because they know many organizations struggle to secure containerized environments properly. One of the most common consequences of Linux server compromise today is cryptojacking. Instead of immediately destroying systems or stealing data, attackers quietly install cryptocurrency mining software. Since Linux servers often run 24 hours a day with powerful CPUs or GPUs, they are ideal mining targets. The victim may simply notice slower performance, higher electricity costs, increased cloud billing, or unusually high CPU usage. Some infected systems continue mining cryptocurrency for months before administrators realize anything is wrong. Ransomware targeting Linux has also become a massive threat. In the past, ransomware groups mainly targeted Windows environments. But modern cybercriminal organizations increasingly focus on Linux servers and enterprise virtualization systems like VMware ESXi. Encrypting Linux servers can completely cripple businesses. Websites go offline, databases become inaccessible, cloud services stop functioning, and customers lose access to critical systems. Many ransomware groups now use double extortion tactics, stealing sensitive data before encryption, and threatening public leaks if the victim refuses to pay. Exposed databases are another major danger. Security researchers frequently discover publicly accessible MongoDB, Redis, Elasticsearch, PostgreSQL, and MySQL databases with no authentication or firewall restrictions. Attackers use automated scanners to locate these systems quickly. In some cases, they steal sensitive customer information. In others, they simply wipe the databases and leave ransom notes demanding payment. These incidents are especially frustrating because most could be prevented with basic network security practices. Home lab enthusiasts are also increasingly vulnerable. More people than ever are self-hosting services like Nextcloud, Jellyfinplex VPNs, and game servers from home internet connections. Self-hosting is empowering and educational, but many hobbyists underestimate the security risks involved with exposing services directly to the internet. A single misconfigured reverse proxy, weak password, or outdated plugin can create a dangerous entry point for attackers. One critical reality people need to understand is that attackers do not necessarily care who you are personally. Many attacks are opportunistic. Cybercriminals want computing resources, bandwidth, access points, or systems they can add to botnets. Even a small VPS server with low traffic can become useful for launching attacks against others, hosting malware, mining cryptocurrency, or hiding malicious activity. Automated attacks do not discriminate between giant corporations and individual users. The rise of AI infrastructure has also increased the importance of Linux security. Most AI servers and GPU clusters run Linux. These systems are attractive targets because they contain expensive hardware, valuable models, proprietary data, and enormous computing power. As AI adoption continues growing, attackers are paying more attention to Linux-based AI environments and cloud systems. So what should Linux users and administrators do right now? First, never expose unnecessary services directly to the public internet. Use firewalls aggressively and block everything that does not absolutely need external access. Restrict SSH access whenever possible. Disable password authentication and use SSH keys instead. Remote root login should almost always be disabled. Tools like fail2ban can help block repeated brute force login attempts automatically. Second, update systems consistently. Security patches matter. Delaying updates creates unnecessary risk. Administrators should monitor security advisories for their Linux distributions and apply patches quickly, especially for internet-facing systems. Automated updates may be appropriate for many environments. Third, use strong authentication everywhere possible. Weak passwords remain one of the biggest causes of compromise. Multi-factor authentication adds another critical security layer. API keys, secrets, and credentials should never be stored carelessly or hard-coded into repositories. Fourth, monitor systems continuously. Security is not something you configure once and forget forever. Administrators should regularly review logs, monitor resource usage, check for unusual processes, and investigate suspicious outbound connections. Unexpected CPU spikes, strange network traffic, or unfamiliar services may indicate compromise. Backups are also essential. Ransomware can destroy businesses overnight if reliable backups are unavailable. Offline backups provide critical protection, but they must also be tested regularly. Many organizations only discover backup failures after a disaster has already occurred. The cybersecurity landscape is changing rapidly. Attackers are becoming faster, smarter, and more automated every year. AI-assisted attacks, automated vulnerability discovery, and large-scale scanning operations are increasing the speed at which systems are compromised. The old assumption that nobody will target my server is no longer realistic. Every internet-connected system is constantly being scanned and evaluated for weaknesses. Despite all of this, Linux itself is not the problem. Linux remains one of the most powerful, flexible, and secure operating systems available when managed correctly. The real danger comes from misconfiguration, neglect, poor maintenance, and lack of awareness. Most major Linux compromises are preventable with proper security practices. The internet today is a non-stop battlefield of automated attacks and defensive measures. Somewhere right now, bots are scanning public IP addresses looking for exposed Linux systems. They are searching for weak passwords, outdated software, open ports, and forgotten configurations. If they find an opening, they move immediately. That is why this warning matters so much. More than 800,000 exposed servers do not just represent statistics on a report. They represent businesses, developers, creators, students, and organizations that may not realize how vulnerable they are. In a world where Linux powers so much of the modern internet, security can no longer be treated as optional. One outdated package, one exposed service, or one weak password can be all it takes for attackers to gain control.